This is Mainak and you're watching Civil Bros. So today we are going to design a G+1 building in STAAD Pro and RCDC. So here's this is center line of the building. Ideally, we should consider ground floor. This is the ground floor, this is the first floor, these are the elevations. So ideally, we should consider, the beam positions as well, as you've seen in my earlier lectures. But for the sake of simplicity, we'll consider only the column positions and only on the primary beams. Okay. You already know how to consider the secondary beams, so we'll just proceed with the primary beams. We'll find out the coordinates, design the building instead, and then as per the soil test report, design the piles in RCDC, and just finish the designing the building. Okay, so let's get started. And if you are new to this channel, make sure to subscribe, and also if you are watching this video, make sure to like, because it helps the YouTube algorithm and encourages us. Okay, so first of all, this is the plan. And first of all, for importing instead, we need to find out the coordinates. So let's take multi-line text here, and we'll just find out the coordinates here. Let's consider this as 0, 0. Just 0, 0, and okay, this disappeared. So let's take this. Let's say this will take, and so this is 0, 0. Okay, and this is thing, and the next coordinate here, it is 3780, right? So in STAAD, this it's in meter, so 3.78, 0, and then you have to add this. So it is 3.78 plus 2.4. So let's open the calc. So here it is a 3.78 plus 2.4 equals to 6.18. So it is 6.18, 0, and the next one, it is a 3.78. So just write here plus 3.78 equals to 9.96. So this is equals to 9.96, and this is done. And we'll copy the same coordinates in the top level, because the x coordinate here will remain the same. So just to copy this, and we'll just change the z coordinate, right? Here, so this is 3.92. So just make sure this second coordinate here is 3.92 everywhere. We can also copy this, Control plus C, and then we'll just paste it everywhere in this. Paste, double click, select this and paste. Just move it a little bit, because it will go upwards as well. We need to be comfortable in this. Okay, and then we'll just move the same coordinate, the top here. So here it will be 3.92 plus 2.885. So it will be 3.92 plus 2.885. It will be 6.805. So just write there 6.805. So just select this, and 6.805. You can just copy this, and then select this, paste, selected this, and then paste, selected this, and then paste. So this is done, and copy, and 6.805 plus 3.335 plus 3.335, it comes 10.14. So 10.14, 10.14, 10.14, 10.14. So these are the coordinates here, and then we'll go for importing this instead. So you can just do this manually, or I prefer to do it in Excel. So I'll just open a new Excel sheet here. First of all, I'll just make a folder here. STAAD G+1 design. Okay, this, and I'll just make a new folder here for the stat file, because in the stat file there a lot of files are created. You don't want to have anything else. Stat file, and then I'll make a folder for, you can have the RCDC files here. RCDC files do not generate much things, so I'll just open new Microsoft Excel worksheet, and these will be my stat coordinates. So this is X, Y, and Z. Those who watched my lectures, you know, the Y coordinate and Z coordinate and STAAD and this AutoCAD are interchanged. So you know it, but if you don't, you know it now. So no problem. Okay. So we'll just insert the coordinates here, and here will be your node number. Okay. So 1, and it's equals to this plus 1. This will do first coordinate is 0, 0, and 0. The next coordinate which we need is, we can do an arrangement, just minimize the Excel sheet, drag it like this, and drag it like this, drag it in left right side, open AutoCAD, maximize it, drag it like this, paste, be careful, drag it like this, and drag it like this. Now we can just enter the coordinates in Excel. So it's 0, 0, this 3.78, y is 0, and the next coordinate is 0. This the 3, number 3, it is 6.18, and then it is 0, and then it is 0, then it is 9.96, 0, 0. So I will copy these 2 for the next 4, that is next level, and only in the Z we'll write here 3.92, and we'll just double click on this 3.92, and then again we'll copy this 4, just paste it, and okay, this one also should be copied. I just can just press here, and then here you can write 6.805. Select this, click on here, double click on here, and 6.805. Now click on here. I need to go further. There. You click here. Now you will work here. So 0. Okay, this both of this copy and paste here. And then you will just write here 10.14. Click outside and double click here. So here you have the coordinates. Just select this, double click here, and you have this nodes. So we are done with this arrangement of this requirement, and just minimize this. Only we're going to create the primary beams for this, finishing this quickly. Open STAAD Pro Connect Series, and till it opens, I will just copy the folder location in which we want the file. So just double click this, select this, copy. So folder location copy, just close this connection client, and folder location has been copied here. And after this, wait till this opens. Okay, this is opened. Connect series new. Okay, just structure, I'll write G+1 particular, and then browse, and then we'll paste the folder location. Okay, folder location is not being pasted due to some reason, I don't know. Okay, let's go to desktop, and then what is the name? STAAD G+1 design, STAAD file, select folder. Okay, folder selected. Select metric, that's important. And after selecting metric, and just click on create. Folder selected, and now you can see XYZ. So along with the node, just copy this, Ctrl+C, select it, Ctrl+V, okay, coordinates done, view, and view, top view, okay, top view done, top view is done. And then you can select all the columns here. And first of all, we'll just go to geometry, and then we'll go add beams, and then we'll add the beams here. All the primary beams we're adding, because we have taken only the coordinates of the primary beams. Ideally, you should take the coordinates of, you can see in my other videos, secondary beams also you need to take. The location of the beams is dependent by the location of the walls. So wherever there is wall, you need to provide a beam underneath. So you know this, ideally, I always recommend you join from left to right and bottom to top. There is no hard and fast rule, but it helps to, organize the model better. That's it. Okay, so since all these are column locations, so now first of all we'll go to select and node cursor and select all the nodes. And since all these are column locations, we will just make room for the foundations, because all these will go below. So you just open the CAD file, you can see what is the foundation depth given here. You can see here the foundation depth is given 7.5 plus 13.5. So, no, sorry, plus on the plinth level, it is actually 7.5 plus 13.5. So, if this is the PL, just roughly, you can see, just calculate here 7.5, sorry, 0.75 plus 1.35. So, it will be 2.1. So, 2.1 meter we can consider from this to the foundation level. Just go to geometry and go to your translation repeat. You can know the symbol of the translation repeat. This is the symbol of the translation repeat, and y direction, and this will be minus 2.1 because we're going below. Just click here and then click on OK. So something has been done, and we'll go to this view, full isometric view, and then we'll go to geometric and add beams, and we'll add the beams here one by one. Make sure you don't make any mistake, otherwise there could be error. Okay, so join one by one. Okay, like I did a mistake, so it's asking me to add node. So I canceled it and I'm starting again. And if you are not comfortable, make sure you zoom. But if you zoom in, zoom out too much, then you might end up being confused. Okay, so don't do this too much as well. Okay, so now just click on escape, and after you click on escape, just go to view and go to the front view, select this structure, and then we'll just go to your geometry. Translation will repeat, since we are considering the same, this only the primary view, that's where it's possible. Otherwise, we need to import the coordinates of the first floor separately, as we've seen in earlier videos, as you'll see. Okay, so y coordinate here, and then we'll just go by the height, floor to floor height. So we need to see the drawing, what is the floor to floor height is given. So let's see here. Here it must see. So it is taken 3.2 meter from the floor to floor height. It's not properly delimited, but okay, it's 3.2 meter. It's supposed to take, I think, okay, we'll just adjust this 3.2 meter. So 3.2 meter is the floor to floor height, 3.2. Just click here, 3.2, and then click on OK. So this has been done. And again, we'll go to the isometric view, and then we'll just go to geometry, and here we could have inserted add just connect, but sometimes it leads to error, so that's why I selected this method. Okay, so here one by one. You need to just do this very carefully, and just have a look at the structure first properly, and just before designing, just make sure you have everything in your head. Then uh, it's easier to do these things, right? Okay. So this is the G, and once the G is done, it's very easy. View, go to the front view, and click Escape a couple of times. Just select this along with the columns, and then we need to have add a floor. So go to geometry, and we'll use a good old translation repeat. Y direction 3.2 meters is what the designer wants, and click on OK. So this is done, and here we have a utilities. Okay, in the utilities, okay, just go to select node cursor and select the bottom nodes, and we have the utilities and node tools. Node tools assign supports, create, fix support, assigned to use cursor to assign. Okay, cursor to assign. Let's see, and you can go to view, isometric view. All the bottom nodes are selected, assigned. So they denote the connection between the column and the foundation. In this case, the column and the pile cap. Okay, so this is the denoted. Click on escape, and you get the beam cursor back. Now you can see the structure here again. This is the staircase portion. So now we need to just go and provide the loadings. Okay, so we'll go to the loading. First of all, this building is in zone 5, so we need to provide the seismic definitions. Use the latest code here for the seismic parameters, IS 893 2002-2005, and click on generate. And just go by zone, that's easier. Zone 5, special moment resisting frame, always all general buildings, then soil, medium soil, and RC frame buildings, and damping ratio 5%, and click on generate, and this is done. Click on add, and then close it. And we'll add some loads here. Okay, you can just do it later also. Just add self weight, and then we'll member weights. Just go for U and I, and then we add the member weight of let's consider 15. If you are considering all 5-inch walls, let's see what walls is considered. Okay, all walls he has considered. Okay, all walls is considered 5-inch walls. So it will be 7.5, right? 7.5, click on add, and then we can just add a load for the parapet as well. Parapet, let's go for 3 for parapet. And then this element weights, and then the floor weights. So floor weights, first of all, let's give the range here for the particular slab weight. This will be in these 2 floors. So the range will be the Y range. Y range will be from this is 3.2 meters, the photo to right. So let's give 3.1 to 3.2 into 2. It's 6.4. So let's give 6.5. Okay, so it will minimum will be 3.1, maximum will be 6.5. So this is the range for adding the slab load as well as the live load for these 2 floors. So the pressure for the slab loads, if you consider, let's see what slab he has considered. This slab section, yeah, slab section 125 mm. So let's calculate what is the slab dead load. We're not going to provide slab here. So 0.125 into 25, it comes as 3.125. Okay, 3.125 is a slab load, and if we consider the floor finish of 0.5, just add 0.5 in here, 0.5, so it will 3.625. And along with that, if we consider according to IS code, if the live load is 2, then we consider 25%. So 25% of 2. First of all, let me write 3.625 here. Otherwise, I'll forget 3.625. So 25% of 2. If it is more than 3, then 2, then it is 50%, right? So 25% of 2 into 0.25, it is 0.5. So then 0.5 should be added here. 3.625 plus 0.5. 3.625 plus 0.5 is equals to 4.125. So 4.125 will add here directly. Finishes everything. 4.125 and click on add. Okay. Load has been added. Now this also we can add here. Just let us finish all the things in one go. Okay, so select 7.5 here. So go to view and go to the front view and select this and control and select this. So this is already selected. Assign to selected beams, assign, and yes. And then we'll load of 3. For that we need to just select this and right click, and then we'll go to new view and click on OK and go to top view, and then make sure this is selected. Then go here, except the staircase portion. Okay, staircase portion, you know this, in this portion there is a staircase. Just select everything and assign to selected beams. Sorry, assign to selected beams, assign, and yes. And the staircase portion, make sure you give the load of 7.5 again, assign to selected beams, assign, and yes. Same thing we're going to do below, load case, and first of all go to display whole structure, and load case details we're going to add here. First load will be the seismic load. Go here, SLX, seismic load again, and this will be in the Z direction, SLZ, SLZ, and then the dead load will be a DL, and then the live load. Seismic load, just add the seismic load here. Go to seismic. Always consider, you can consider maximum always. Factor is 1. Seismic load in Z direction. Add this. Go to seismic. Z direction. Factor is 1. Dead load. Just add the dead load here. First of all, self weight factor is -1 now. It's not seismic, so that always the factor will be negative or positive. So factor is -1, obviously. And then you have this just add is your member load, the same as you have added. This will be a -7. What we had taken earlier, it was taken 7.5, right? So this one 7.5. Y direction, because it is going from top to bottom. The seismic, we don't need to add directions, right? So -7.5, and then go add here member load of -3. Click on add. I've added 2 times, so I will need to delete 1. Okay, now it's good. Okay, so and the floor finish load plus the slab weight. So we have already calculated that. Calculated that. So it was 3.625. We had calculated that floor finish load plus slab weight 3.625. So just apply that load, add. We go to floor loads, and it will be -3.625. Range will be the same, minimum 3.1 and maximum is 6.5. Okay, 3.2 was the height, so okay, 6.5. It's good. Click on add and close. So here self weight, just assign to view, assign, and then 7.5 view, the front view, and assign to selected beams, assign, yes, and then 3. For the 3, we need to select this and right click, and then new view, just click on OK. Go to the top view, and here in this 3, select all the things which, like this is similar to the one which we done earlier. All the things which are not in the parapet walls. Where you have the parapet walls, just select this assign to selected beams, assign, and yes. And here we'll have the staircase. So full walls will be given. Yes. Live load, add live load. It will be this floor load and -2, and the range will be the same 3.1. Okay, 3.1 to 6.5, and close display whole structure. Right. So you can see these loads, and self weight is already assigned, right? All loads are assigned. So now when all loads are assigned, first of then we'll need to assign the properties. So go geometry and then properties, and click on define rectangle. So let's see what he has. This drawing was given him to check only, okay, by some other designer. So let's see what he has given, and let's see whether the the structure is safe or not. So this is the short span, this is the long span, and this is the thing. So let's see where he has given the column sections. Yeah, here. So column he has given 300 and 300, and beams he has given 300 into 250 into 425. It's called 425, 425, and he has given 15 to 4. Okay, so lintel and L and tie beam. Okay, so this is three. Okay, let's take the beam 250 into 425, and the columns 300 to 300. Okay, let's do it. So beam is, first of all, let's take the column here, 0.3 into 0.3. This is the column, and add the particular your beam. So it is 250 into 425. That's what he wants, right? 425. Okay, that's what he wants. Add and then close. Okay, so then now let's take the column here. First of all, the column. Click on you can click on edit to check this is the column or not. Okay, so now go to select and select geometry parallel to, sorry, not this one. This beams parallel to Y, and assign to selected beams, assigned and yes. And this one, and this beams parallel to X parallel to Z, and assign for the ones. Okay, all beams same size, but we can have different sizes as well. Okay, so this is what is the property assignment. And if you want to just missing property check, just missing anything missing property, you can check. There is no missing property, so it's okay. And after that you go to analysis. Just this here you can add analysis commands, and just no print, and then click on add. Okay, after that we can go to design, and in the design you can just select the, first of all select concrete here, then you have the Indian code selected. We are designing by IS codes. Select parameters, bring all the parameters here, clear cover, and then compressive strength of reinforcement. Let's take this first, and if anything is missing, we'll see. Minimum main, minimum secondary. 1, 2, 3, 4, 5, 6, 7, 8. Okay, I think it's enough. Click on OK. Commands, design beam, design column, take off. We just get the quantity. Optional, you can add or not add, it's to you. So here Okay, now you need to define everything. So design beam, first of all, we define. So we'll go to select and select parallel to X, parallel to Z, and then assign. And yes, design columns, parallel to Y, assign, and yes. Okay, so this is done. And now we need to define the other things. Okay, just you have this all these things, constants, supports, these have been defined, load type. So then you need to click on define parameters and clear cover of columns and beams. So let's go with 40 mm. I'll just keep clear cover of columns as 40 mm and beams as 30 mm. And FC, that is the compressive strength of concrete. We use M20 concrete, 20 and 1, 2, 3, 20,000, and click on add. And FY main, 550 bars are used now. So let's see if he has given anything detail in this reinforcement detail. So I think this has not been given, but now IP 550 bars are used commonly. So we use IP 550, 550, and then 1, 2, 3. So this is it, and for secondary also same 550, 1, 2, 3. Click on add maximum main, and maximum main will use 16 mm. That's what he wants. Minimum secondary is 8 mm, and minimum main is 12 mm as per IS code for the columns. Secondary, minimum secondary is 8 mm. I've done one error, I think. Maximum secondary, I need to change this. So right click and then edit command, and maximum secondary we can do this 810 modify. Okay, so when this modified, just clear cover and select already there, select to Y. This is the clear cover for columns, assign, and yes, select cover for beams and parallel to X, parallel to Z, and selected beams assigned to yes, and this assigned to view. Everything else is more or less assigned to view. So we go to analysis and designs and go click on run analysis. Everything is okay, then we can just we'll get the result, otherwise we'll get an error. So I hope everything is okay, we don't have any errors, and we are done here for the stat. Now only for the this other things we need to do in the RCDC. So just click on save. Okay, no change, so no need to save. Just close the file here, and the folder, our favorite folder in which we have designed. In this, we'll save the RCDC file. So just open the RCDC. Accept. So this project details, I'll just enter here. Okay. Entered. So just we'll just go to and enter, find out this stat file here, G+1 design, and just open this. Okay, open. Okay, first of all, we need to design the uh, column. Okay, after the column, we'll go to file cap. So create new project. And this new project needs to be saved, Ctrl+S, and we'll need the save it outside. This is RCDC DC column design. Save. Okay, then first of all, go to settings, design settings, and here we don't. You can select the ductile design if you want. This is for seismic resistance. This project doesn't have any requirements, such requirements, so will not select this. For big projects, always you need to select this, as you have seen in my earlier videos. Okay, so ductile design not required. Basic load cases here. This will be seismic load in X direction, seismic load in Z direction, dead load, live load, select everything. Okay. Then just design. Yeah, 300 to 300, everything is passing, even in even in this FE415 it's passing. So when you can change this everything to this redesign and M20 and FE415 we can do this, but it's passing, so no problem in this part. So I'll just go and quickly just save the this files, the design files. We'll save this. So reports, and we'll just go here, design summary, and control plus P here, and print. So it will be the RCDC. Okay, column, design summary, and then we'll have the next reports, design calculation for all columns. Column design calculation. So this is all we need for now, and just to close this file. Yeah, obviously we want to save the changes. Who doesn't want? So then we go for the next file. Just open RCDC. Next we'll go for the file, super file. So here we can see the column which is the designer's provide is okay. Smooth, and it provide 8 reinforcement. So this is okay. And stat file, just select the stat file. And this time we'll go to file cap. So let me just fill in the details real quick. Create new project, and this will be done. Okay, so then we'll have this file. We'll save this file first. So just RCDC. Now in place of column, it will be what? Foundation. And we'll import the column data. And we'll go to the settings. Okay, before going to settings, pile report, let's check the pile report and pile capacity. So here, this is the pile capacity. So we'll take the minimum one, 450 mm, and recommended is 74. Okay, 74 is the recommended one. So let's calculate here 74 ton. So 74 into 1000. This is the amount in kgs into this 9.81. This is in newtons, divided by 1000. This is in kilonewton. Okay, let me check this again. Okay, so 74 into 9.81. So recommended safe pile capacity is 725.94. So let's take 726 we can take, or 725. I'll take 725 for the 12-meter pile, 450 mm dia. Okay, so settings and pile capacity, pile diameter 450, compression capacity, what we have this 725, and tension capacity is 725. Shear capacity by default it's 200, so 200 in kilonewton. Click on OK, and then we'll go to settings, general settings, M25 or foundation always M25, and FE 550 is the reinforcement which is used. Okay, I'll just click FE 500. Let's click FE 500 for now. But FE 550 is the reinforcement which they will use, so FE 550, and pile diameter 450 mm. 3, 4, 5, 6, all the these are allowed. Click on OK and click on settings, and here crack with the one basic load cases, seismic load. This is seismic X, this is seismic Z, this is dead load, this is a live load, and select this everything and go here, click on OK. This regular structure sizing for regular structure, OK, and then just a file combination. All the combinations, we have 3 file, and here, and then we design this file gap here like this. So these are done here for this file, and but I think in this he wants 4 file. I think yes, he wants 4 files. Okay, if you want 4 file, then what to do? Go to general settings, and okay, first of all you have to unlock the design, right? So let's go to design and unlock design. Okay, and go to settings, general settings. Okay, settings, settings. This is okay, visible, and general settings. Okay, I'm not able to change it now. Okay, is it unlocked or locked? Unlock file configuration. Okay, file configuration unlocked. Okay, now we can change it. Okay, now number of files, we want 4. We want 4 only. Okay, because he wants 4, we want 4, and but in 3 it is path for T+1 building. And again, compulsorily I cannot do this. Settings, general settings. Let's see, file diameter 450 mm. Available numbers only. I'll just select 4. For 5, 6 I can want only 4. No, 3 is not an option. Click on OK, and then you have file configuration 4, and then you have design. Correct. So now it's up to his expectations here. Here I think I need to change some things. So we'll go to reports, and this is a design summary, and design summary. This okay. Design summary is okay here, and I'll just save this, but before saving I need to just have some changes in this. Okay, this file cap design summary is there, and just need change the name, and just click here and Ctrl+P, and here we'll just print this, and this will be column, this design summary, right? So this foundation, because a column FUNDATION foundation design summary, save, and then report, and then you'll have this design calculations, all file cap. Click on OK, and then Ctrl+P, and print this, and just wait for some time, and this will be foundation design calculation, and CALCULATIONS calculations, and click on save, and then we're done for this, and then we'll just close this. Okay, you need the file configuration, this file as well, so we'll just save this file. This will be file layout. Okay, just close this. Let's go for the beam designs, and go to RCDC once again after closing, because You need to close one for starting one. I'll just fill in this details here. Copy paste. Okay, just select the file. And here, when you select the beam design, you have this level. So you have beams on all these levels. When you have similar, this might work. Otherwise, you need to select all the levels individually. So let's see if this works or not. Otherwise, we have to select all the levels individually. So since I think this uh, has worked because all the thin beams have the same configuration and same layout, so that's why it worked. Otherwise it would be difficult. So just to go to general and reinforcement settings, M25. Okay, we'll use M25. We'll specify that in that, and FE550 reinforcement rebar settings. This is okay, and just click on OK, and then go to settings and basic load cases. These load cases we'll just import here dead load. So not dead load, this is seismic load in X direction, seismic load in Z direction, and this dead load, and this is the live load, and we select all this, and then we import the combinations for regular structure. Click on OK, and then we design. I think all it will pass. So this is it. All beams are passing, and you can see reinforcement is also pretty much 316, 312. If we provide 316 and the top and bottom, everything will pass. So this is it. And just go to report, and we'll have project summary. We'll save the project summary here. Ctrl+P, print. This will be our beam. Okay, the project summary, right? Beam design summary. And reports and calculation. Beam design calculations, just write beam in place. Done. So we are up, we have completed the design. Okay, see you, bye.